Hi there, in this video we're going to talk about z-scores and normal distribution. So what is a z-score? So a z-score allows you to find the percent of your bell curve or your normal distribution curve that's under the curve that's not your typical percentages that they give you by just adding or subtracting whole number standard deviations. So I put the definition on here. It says the measurement of how many standard deviations above or below the mean value is. So basically what that means is if you look at your typical bell curve, I'm just going to scroll down here to show you. So if I look at my typical bell curve, I want to find out, like, if I want to know the percent between the mean and one standard deviation, I know that it's going to be 34% of my data. But what if I want to look at like 1.2, how much of my data am I really talking about? So that's where the z-score comes in. So it allows you to look under your bell curve using the percentages, but you don't have to guess. It gives you an actual value. Okay, so what we're going to do is we're going to, if that happens to us, which everything is not always just like one standard deviation away, okay, most of the time it's probably going to be some type of decimal. We want to find what our z-score is, and then we're going to use a table to look up and tell us what the percentages of our normal distribution are. So to find z-score, we're going to take the value that you're looking at, and then you're going to subtract the mean, which is the Greek letter mu. This little, like, it looks like a U with a really long tail. And then divide it by the standard deviation, which is the Greek letter sigma. It's the lowercase sigma. I'm sure you've seen the uppercase sigma looks something like this. Okay. So then we look up our z-score in the chart below to tell what percent of the bell curve we have. And you have to be careful because there's a positive z-score chart and a negative z-score chart, depending on if you get a positive or negative answer. So I copied and pasted both the charts in here. These are from ztable.net, but I wanted to reference them next to each other so you could just kind of see where you're at, and we'll talk about how to read it in a minute. Okay, so I think the easiest thing to do is to understand by example. So we're going to go back to our same Jim Snow who sells trees. It says the mean length of his trees purchased was 68 inches with a standard deviation of 10. What percent of his sales were more than 84 inches tall? Okay, so here's what I have to look at. If first thing I'm going to do is I'm going to say that my mean is equal to 68 inches and my standard deviation is 10. Okay, so on my normal distribution chart, I'm going to say, okay, that means literally that my mean value is 68, and I'm going up by increments of 10 because that's what my standard deviation is. So this would be 78, this would be 88, this would be 98. And then I go backwards. This would be 58, 48, 38. Okay, so if the problem said, how many percent of my trees are taller than 88 inches? Well, I could say, oh, well, that's easy. That's this section of my graph, and I'd add my percents together. So that would give me 2.5. We're like, okay, cool, but they want 84 inches. So 84 inches, obviously, is between 78 and 88. It's going to be somewhere probably around here. But we can't guess and say, oh, well, that's this just easy percent. Okay, so what we have to do is we have to find the z-score to help us figure out how much of the percent we're talking for our graph. So here's what we do. So our z-score, we use our formula, is x minus mu over sigma. Our x value, because we want, is 84. That's the number that we're looking for. And our mean is 68. And we divide it by our sigma, which is 10. So this gives me 16 over 10, or 1.6. Okay, it's a positive number, so I come to the positive chart. The positive chart's on the left-hand side. So I go down here and I find 1.6. 1.6 is right here. And my answer is exactly 1.60. If it was like, let's just say 1.62, I would scooch over here where there's an extra 0.02. But I'm just at 1.60, so I'm looking right here. And it gives me my number, 0.94520. So I get 0.94520. Okay. Let's change it into a percent because that's the information that we're looking for. As a percent, this is the same as 94.52%. So this tells me that 94.52% of the trees are below 84 inches. Because it's looking at the whole, we are taking this whole bell curve all the way up to here. But we want to know how many were more than 84 inches tall. And remember, under the bell curve is 100%. So if I want to figure out how many is more than 84 inches, I take 100% minus 94.52% minus 94.52 gives me 5.48%. So that tells me out of all of Jim's trees, 5.48% of them were taller than 84 inches. So let me know if you have any questions about a Z-score, what it means, how to read the chart, and how to interpret the data. Good luck.